Good morning, students. Today we are going to learn a new chapter. But before we start our chapter, let us consider few examples. A book lying on a table, a photo frame on the wall. Are these at rest or in motion? Yes, they are at rest. Now, consider birds flying, planets revolving round the sun, vehicles moving on the road. All these examples, we say they are in motion. All moving bodies change their position with time. Sometimes an object may be appear to be at rest for some, but to be moving for some other people. Consider a bus moving. For a person standing on the road, when he observes the moving bus, he finds that the bus and the people in it are moving. But for a person who is inside the bus, his fellow passengers are at rest. So, today in our lesson, motion, we are going to understand about motion more comprehensively. Now, we will consider a reference point. What is meant by a reference point? Let us understand by taking an example. Whenever we talk about the motion of an object, we have to take a reference point. This reference point should always be a stationary object, something like that of an electric pole, a tree, or a building. Whenever we talk about the position of a moving object, that means how far or near it is with respect to another object. We have to consider a reference point, a stationary reference point, which is called origin. Consider that your house is 5 kilometers from our school. We have mentioned that the position of your house with respect to the school is 5 kilometers. Here, the school is taken as the reference point. Now, let us see this slide where a person has to reach his house. He has two different paths to reach home. One path is shown by a blue dotted line with an arrow. First, he walks 4 meters towards the tree, and from the tree, another 3 meters towards the house. So the total path length traveled by the person is 4 meters plus 3 meters, 7 meters to reach his house. This is termed as distance. Now, look at the other path shown by a red line. Here, he walks 5 meters to reach his house. The path that is shown by the red line is the shortest path from the starting position to the final position. This is known as displacement. Now, let us look at another example. To reach the destination or the place where we have to go, there may be number of paths. The total path length covered from the start to the end is the distance, and the shortest path length, which is one and only one path, is known as displacement. Now I think everyone is clear with what is distance and displacement. Now, before we understand the differences between distance and displacement, let's learn two important quantities which are scalar and vector. Any measurable quantity, that means any quantity that you can measure, if it has only magnitude and no direction, it is called a scalar quantity. On the other hand, the quantity which has both magnitude as well as direction is called a vector quantity. In our 8th class, we have learnt force and pressure lesson. Is force a scalar quantity or a vector quantity? Force is a vector quantity because it has both magnitude and direction. Now that we understood the difference between scalar and vector quantities, let us discuss the differences between distance and displacement. The total path length travelled by an object is distance. The shortest length between the initial and the final positions of an object is displacement. Now, let us see whether distance is a scalar or vector and displacement is a scalar or a vector. When we talk about distance, we don't specify any direction. So, distance is a scalar quantity. Displacement is the shortest path. When we say the shortest path, we are indicating a direction. So, displacement is a vector. Now, before we consider the other 2 points of difference between distance and displacement, let us see an example. A person walks 2 kilometers from his house to go to a medical shop. He takes his medicines and returns back. What will be the distance covered and what will be his displacement? The distance covered will be 2 plus 2, 4 kilometers. But displacement will be 0 because he returns back home. He travels plus 2 kilometers towards the shop and minus 2 kilometers to return home. So the total displacement is 0. Now we can say that the distance will always be positive. It can never be negative or 0. But displacement can be positive. It can be even negative or 0. The last point of difference says that distance can be either equal to or greater than displacement, but displacement is either equal to or less than displacement. Displacement can never be greater than distance. Now, we are going to learn 2 new terms: uniform motion and non-uniform motion. Consider that a person is covering a distance of 10 kilometers for every 5 minutes. That means an equal distance of 10 kilometers in an equal interval of time, 5 minutes. then it is uniform motion. The object or the person is said to be in uniform motion. When an object covers equal distances in equal intervals of time, it is said to be in uniform motion. The movement of planets around the sun can be taken as an example for uniform motion. If you consider vehicles moving on a busy road, they cannot cover equal distances in equal intervals of time. Sometimes they may move fast, sometimes they may move slowly. Such motion is said to be non-uniform. That means when a body covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. In the next module, we will be learning about rate of motion. What is meant by rate of motion and how to measure the rate of motion. So for today, we will conclude our class here.